Okay, hello. This is 2016 step 2 question 9. It's a mechanics question that was relatively poorly answered. I would say it's actually an easier question if you know how to approach it. It requires you set up a lot of things yourself, and so feel free to give this a go yourself and see how you get on. This video is just going to be my approach to solving it, and how the most important thing you can take from this video is not the actual method I use for solving it, but more what it is I did that allowed me to know what to do and not get confused and sort of mixed up, because it's a very unstructured question. So if we have a look at this question, it says a small bullet of mass M is fired into a block of wood of mass big M. So like all mechanics questions, the first thing I'm going to do is quickly draw out a beautiful diagram. Art is not my strong suit. So we've got a small bullet. That's M. Okay. And it's at rest. The speed of the bullet on entering the block is U. Okay, so we've got U. And in fact, I'm going to make this slightly more, I'm going to make a small change here because we've got the bullet entering the block. So we sort of want to show it's right next to the block at first. So we've got this guy going that way at U. Its trajectory within the block is a horizontal straight line, and the resistance to the bullet's motion is R, which is constant. Okay, and so in terms of forces on the bullet, all we've got is R backwards. Okay, the block is fixed. The bullet travels a distance A inside the block before coming to rest. Find an expression for A in terms of M, U, and R. Okay, so this first part is not really worth very many marks at all. What have we got? We've got a fixed resistance to motion. And so, to be honest, we can do whatever we want. We can have SUVAT, or we can have energy considerations. Either one will work. So I'm just going to use energy considerations, e.g. Kinetic energy of the bullet at first is mu squared over 2, and that must be sort of converted into work done against the resistance. So in other words, force times distance will equal work done. And so we've got, well, the force is R, the distance is A, and the work done will be the kinetic energy of the bullet. And so we immediately get that A is equal to mu squared over 2R. Okay, that's not the difficult bit of this question. It's probably only a couple of marks. And so now we get to go on to the much, much harder bit of the question. So if I tidy this up a bit and just keep that final result. Now let's see what's going on in the second bit. And it's a bit deceptively, it looks deceptively simple. So instead, the block is free to move on a smooth horizontal table. The bullet travels a distance B inside the block before coming to rest relative to the block. At which time the block has moved a distance C on the table. Find expressions for B in terms of B and C in terms of M, M, and A. Okay, so hopefully it's relatively clear that actually this question, they haven't given us much to go with. It's quite hard to know what to start by doing. So in that situation, which you will find yourself in STEP a lot of the time, all you want to do is just start writing down what you can do and just make your diagram as clear as possible. And so because we've got relative motion in this question, keeping track of what everything's doing is going to get a bit confusing. And so we want to make that as clear as possible. So what I'm going to do is I'm going to say that this direction is the X direction. And they're both starting. If we just say this point, where the bullet collides, that's X equals 0. Okay, now what we can now do that we've done that is we can define everything in terms of x. And so what can we say? Well, at time t equals 0, e.g., when the bullet collides with the block, what information do we know? Now, I'm not expecting you to know where we're going with this yet. I'm just showing this is what you would want to do if you're not sure what to do. You just start writing down everything you know. So at time t equals 0, we've got the speed of the bullet is u. And so we can say, well, we can call that, because I want to put everything in terms of x, I can say x dot bullet equals u. And I'll call that bt. And I can also say x dot block equals 0, because it's not moving. Okay, fine. Not necessarily obvious why this is useful yet, but that doesn't matter. We're just writing down what we can write down, what we know. At the very least, we'll get some marks for it. Okay, what else do we know? Well, we don't know how long it takes for this event to happen. So let's just call it big T. And then we can say, well, at time t equals t, well, what do we actually know? Well, we know that the easy one is that x block equals c. Okay, because we know the block has moved across the table by a distance c. What about x bullet? Well, that's traveled b inside the block. And so if we actually think about that, well, obviously it's going to be b, but it's also, imagine it didn't move anywhere. Imagine it just stuck to the surface of the block. Well, even if it didn't go anywhere inside the block, it would still move along with the block. So that would go, it goes however far inside the block it goes, plus however far the block itself goes. So we've got b plus c. Okay. And then, is there anything else we know? Well, we can say that, oh, and sorry, one other thing I could have included up here, just because we're writing everything down we can. And x block equals 0 at that initial time. Okay, and so, well, what else can we say at time t equals t? Well, the whole point of this was that we're talking about it until the bullet comes to rest relative to the block. Okay, so whatever they are, we know that they're the same. So what we can say is that x dot bullet must equal x dot block at that time. We don't know what they are, but we know that this is true. Okay, we've written all that down, still not necessarily clear what we're supposed to do. So now let's have a think about, well, what else do we know? Well, actually, even though the situation with the block itself has changed, the situation with the bullet is very similar. We know that this bullet has still just got a resistance to motion r. He's just being forced backwards by r. And due to Newton's third law, that means that we can also say that the only force acting on the block is a forwards force of r. And this is true at all times. So we know that this is true until the bullet is at rest relative to the block. So in other words, true for all t such that 0 is less than t is less than or equal to t. Well, what have we got? We've got the forces on the bullet are just backwards r. So I guess we can just say that, what does that tell us? Well, mx bullet double dot, well, that's just going to be minus r. Now, why is that minus? Well, x is defined in this direction, and so the force on the bullet is backwards, and so it's just acting to accelerate it in the opposite direction. So we've got that, and we can rewrite that slightly nicer as just x dot dot bullet equals minus r over m. And this is true for all t. And then similarly, for the block, we can just say, well, that's got a force acting forwards and of r, so it's just going to be plus r over, this time it's over the mass of the block. Just very simple, F equals ma. Okay, now at this point, we're sort of done, as in only now am I going to even think about how I'm going to solve this problem. And what do I mean by that? I mean, this problem, and feel free to try this first without having actually looked at my solution. But this problem, if you jump straight in, it actually gets very confusing very quickly. And there's no way of checking. They haven't given you any show that's in the question. So it's going to be very easy to spend a lot of time and not actually get to the answer. And so it's quite a high risk question if you don't set it up well. So what have I actually done? Well, I've just sat here and tried to write out as much obvious information as possible in a structured way. And this is what you want to do in sort of all step questions. And that generalizes to difficult PAT questions and MAT questions as well. So hopefully you agree that everything I've written down is not particularly inspired or difficult. It should be definitely doable. And so now that we've run out of stuff that we can possibly write down, we can have a look at what we've actually got and think about what direction it's pointing us in for the question. So what have we got? Well, this is just, this looks sort of like initial conditions, as in just, and same with this, or final conditions, you call this. In other words, they're not true for all time. They're only true at specific times. And so then usually when you get stuff like at time t equals 0, this thing is true. That's usually used in differential equations for finding a constant of integration. And so then if we look down here, well, this is true for all time. In other words, we can integrate. So what have we actually got? What is this writing down the obvious stuff told us to do? Well, it's shown us that all we have here is a set of very simple differential equations. I've just noticed a small typo. So this is x double dot block bullet, and this is x double dot block. So now we have a direction for the question. All we need to do to finish off this question is integrate this and then sub in the initial conditions to get rid of any constants of integration. So let's start doing that. And hopefully it's clear why I've sort of gone down this route. Once I've written down the obvious stuff, I've looked at the clues on what's best to do. And this looks like a reasonable path. So what can we say? Well, we can say these are very easy to integrate because they're just constants at the moment. So in other words, we get that x integrating the bullet one, we get x dot bullet equals minus r over m t plus some constant of integration. If we just very quickly sub in that at t equals 0, x bullet equals u, or x dot bullet equals u. So t equals 0, x dot bullet equals u. That tells us very quickly that x dot bullet in general is going to be minus r over m t plus u. And doing a very similar tactic for the block, we can get x dot block equals r over m t plus c, but at t equals 0, x block is 0, so the plus c goes away. If you sub it in, and so we get that. Okay, and now we can just do the same thing again because, well, why not? So then we get that x bullet is going to be equal to minus r over m, or 2m t squared plus ut plus some other constant of integration, and x block is going to be r over 2m t squared plus some other constant of integration. So now let's go back to our initial conditions and have a look at what we have used and haven't used. So we've already used these guys. We haven't used these, so let's just use those. And all that's going to do is get rid of both constants of integration, so that's nice. And so now we've used them as well. Okay. And so now sort of we've got these expressions and we want, what do we actually want? Well, we want to know what expressions for B and C in terms of M, and A. So effectively, all you should be thinking now is, well, we've not used this stuff yet. So let's sort of start trying to go through and use it and see what this gives us. So let's just take a look at this first, because let's try something that in and see what it gives us. So at t equals t, we have x dot block must be equal to x dot bullet. And so what does that tell us? Well, it tells us that RT over M is equal to minus RT over little m plus U. Okay, so now we've used that guy, and let's just sort of rearrange this. Well, what's going to be helpful from this? What has this actually done? Well, this has told us what T is. So this has told us that T is equal to R brackets 1 wow, let's actually rearrange that. So what have we got? We've got T R 1 over M plus 1 over little m is equal to U. And so that tells us that T is equal to U over R times, this is slightly irritating, but M over M plus M. That's just from rearranging that line above. Okay, so that's given us what the time T is. So what have we got left? Well, all we have left is to sub in for these, and then hopefully we'll be at the answer, because if not, then we're sort of a bit stuck. So, okay, so we've got at time t equals t, we know that the block, x block, is just C. So let's do that. So what have we got? We've got that C must be equal to R over 2m times capital T squared, which is U squared over R squared times M squared over M plus M squared. Tidying that up a bit gives us that C is equal to, okay, that looks to me like it's going to be U squared M should be correct. I'm just thinking, I don't want to go wrong anywhere. Okay. I'm not particularly happy with the units there, but hopefully it will work out. Okay. And then X bullet is going to be B plus C is equal to minus R over 2M. Well, actually, so that's just going to be the same thing, but minus just subbing it in, we'll get minus U squared M squared over 2R M plus M squared. But then we've also got plus UT, so that must be plus U squared M over R M plus M. And okay, so we've got to that. And so now all we need to do is have a look at what they actually wanted. So they wanted B and C in terms of M, and A. So what we need to do is we need to remember that A is the thing we found earlier, mu squared over 2R. So we've got A equals mu squared over 2R. And so we're basically done. We just need to make sure we get rid of anything we don't want in the answer. So we want to keep A, M, was that it? M, and A. So in other words, that means we need to eliminate from our answers. Well, we don't want any U's in there, and we don't want any R's in there. And so once we got rid of those, everything should work out. So let's have a look at that. How can we get rid of, so we want to get rid of U squared and R. So that should, yeah. So in other words, looking at that, we've got that A over M U squared over 2R. And so just subbing that into C, we immediately get that C is equal to A M over M plus M squared. That's one answer. And then B is equal to, well, B plus C is equal to minus M squared, just subbing in for A, minus M squared over, so minus A M squared over M plus M squared, plus, again, we need to get rid of U squared over R. So in other words, U squared over R is 2A over M. So that's going to be plus 2A M over M plus M. And we already know what C is. It's this thing up here. And so we've got that B is equal to 2A M over M plus M minus A M squared over M plus M squared minus whatever C is, which is A M over M plus M squared. And that looks like we can simplify a bit by taking stuff out. So if we just say B is equal to, well, what can we take out of everything? We can take out an A, we can take out an M, We can take out an m plus m. And what are we left with? Well, we're just left with a 2 minus m over m plus m plus m over m plus m, which looks like we can probably simplify even further if we just sort of put that all, how will that simplify? Yeah, that will probably simplify. So let's just do that. We'll get that equals am over m plus m, 2m plus 2m minus m all over m plus m. And so that's actually worked out extremely nicely, because that's ended up being equals am over m plus m. I believe that whole thing cancels out, so that's actually it. And that's the entirety of that step question.